Okay, so just a quick intro into Equal Experts. So just a network of talented, experienced software consultants specializing in agile delivery. It's mostly a UK-based company, but we have offices around the world as well. I'm from the Berlin office. I moved there a year ago to take care of the mobile practice in Germany. So here it is. So the talk today will be about full-stack Swift development, how and why. I'm not going to show too much code in this one because it would be a repetition of much of what we've done so far. So I'm going to try to concentrate on the why, and the how is also going to be about how do we actually get buy-in from stakeholders, from the product people, to actually allow us to do this. So I'm just going to explain where I'm coming from. So I started in mobile in 2006. Before that, I did full stack development and on the side some Mac development. So in 2007, when the iPhone came out, I was in the right place at the right time. Very lucky that way, because it was just an accident that I was working in mobile at the time. And what happened then was, of course, I jumped into iOS development. And not too far ahead in time, so a bit after that, I actually started consulting in London. And eventually I got to on the high street, where I was lucky enough to have Nick Jackson there, who is at HashiCorp right now. And when in 2016 Kitura came out, we were very, very excited to try it out. So we actually built, I think, the first Kitura service in production. Luckily, we had a chance to create a service for a short-lived project that wasn't critical. So we could actually do it, because it was very, very early days. I mean, I think Kitura was released 2 months earlier as an alpha. So Nick had to create a shim just to get a C library to allow us to do MySQL, because there was no way at the time to connect to a database. So that's kind of the bit about me. So I've been, since 2007, mostly working on iOS and mobile in general, but my experience from full stack before that and from working with Nick on this first Kitura service meant that I was very excited about continuing down that road. So I've been trying to push for full stack development ever since, and at every client I've used it in some capacity. So we haven't been able to put it in production in many places, but during the development process and design process we've been able to use it quite a lot, actually. So let's look at the current state of mobile. So all mobile projects depend on an API, and that means there's usually a large back-end team in a silo in bigger organizations that I usually work at that deliver these APIs. So there aren't many chances to actually have the mobile team define what those APIs are. And often we get misaligned roadmaps because of those silos. And another thing that happens a lot is meetings and more meetings, and I think we've all been in that situation. Because of the separation between the teams, we need a lot of management as well, so costs go up quite considerably due to the fact that everything is so siloed. And then, as we talked about, as many people have talked about up to now, there's best practice REST APIs, and everyone's trying to do that. But that is an issue for mobile applications. In many cases, best practice RESTful APIs are not ideal for a client app on iOS or Android, because it might mean that we have to make too many calls to get something done. That's why BFFs exist, and I'll go into that later. And then user stories are often blocked by business tasks being done by the back-end teams. Some technical debt they have to take care of because of how old some of the setups are, and tooling. There's often, there's a new CI system they want to set up, and that creates a lot of issues. Some companies try to get rid of the silos, and they have cross-functional teams, but sometimes that means having to have too many people to get a ticket through. So you would have different technologies in the client side, different technologies in the back end, and it's just very, very high to get anything through. So what if there was a better way? What could a better way of doing this be? Well, full stack development in Swift, I think, is a way forward. This is from my point of view as someone working on mobile clients. You can have a single small team, which makes it a lot easier to get stories done, and a lot less meetings. So you have ideally a pair of one mobile developer with a lot of mobile experience, iOS in this case, and someone coming from the back end who's interested in Swift like you are here. If they pair together as a pair, using XP pairing, you can get a story done full stack with almost no meetings. It's just a pairing session, practically. And you can then focus on a story as one, so you can really cut down on all the noise. So why Swift, and why now? So, well, first of all, iOS. It's the right time for iOS. It's always been the right time for iOS because of this. So if we look at these numbers, it's a metric on the downloads on iOS and Google Play. And this is for 2016, 2017. And you can see actually Google Play is getting more and more downloads, but on the other side, the amount of money spent on iOS is much higher. So, and this is, if we look at how Android works, a lot of devices that are classified as Android are actually more like feature phones. They get purchased by people who don't care about apps. All they care about is having a phone, and it's the cheapest phone they can get with their contract. So this is the number for people who actually use apps on Android. And so with a much smaller footprint, iOS actually makes most of the money. And iOS users are much more valuable. So starting on the client side in iOS makes a lot of sense. A lot of companies don't even start with having a website or Android, they just start with iOS. And if the business model makes sense, they move on to supporting Android and maybe supporting web. In some countries like China, where most of the population never had a PC in the first place. So they went from not having any device to having a mobile device, a smartphone. In those countries, most companies don't have a website. They never did have one. They only have apps. So starting from iOS makes sense. And this is another thing. How expensive is it to create a client? So this is the current state, and this is taken from the dashboard on developer.android. The current state right now of the fragmentation of Android. So this is the installed base right now. So if you want to target Android, you have to target an incredible matrix of device types and then of systems, and this becomes very, very expensive. So even though someone might say, oh, it's easy to create an Android app, it's actually not. And even if you're trying to do some, one of those phone gaps or something, yeah. I'm only talking about native development here because that's the only thing that actually makes sense in my experience. Your experience may vary here, but actually this becomes a problem with any other type of technology. So iOS makes sense, and that's why Swift makes sense. Because if you're going to do iOS, Swift is what makes sense right now. It's mature, really mature right now, and also you can use the same code base partially on the back end. So it's the perfect time. So another consideration is Swift is cheap to run on the server. So the resource utilization is really low. So for many projects that don't require don't have a lot of users, smaller projects, the the cost to run one of these is minimal. It's ridiculously low. And yeah, it's mature enough in the back end now for many use cases. Not all of them, of course, as you well know, as others have talked about throughout the sessions in the past days. It's not ideal yet for everything. There are a lot of issues here and there, but it is mature enough now for many, many, many cases. And, well, user-centric development, something in the client side we care about a lot, is to create things that users actually want to use. Because if you don't have adoption, you can make the best architecture in the back end, have the most amazing code, but it's useless, because if no one uses it, that product's dead. So in order to get that, you need to think from the user onwards. So all stories have to start from the user, and everything has to be from the user's point of view. And that means starting from the client. And if you can then use the same technology and the same team from the client side all the way to the back end, all the way to the database, you're in a much better position. And another thing a lot of people don't think about is the enterprise. So the enterprise market is a place where you can target a smaller group of people. You're not trying to be the next Instagram. You're not trying to have 1 billion users. The enterprise is a market where you could be targeting 50 people, 100, 2,000. As long as there's a return on investment for the company, the target group could be quite small. And this is something I'm going to talk about today as well, because I think a lot of people are not aware of that. But there are a lot of users out there who do not have a desk. So in their workplace, the only way they can interface with any system that their company has is through a mobile application. And creating server-side or full-stack Swift solutions is ideal in this situation, because these are places where Swift is already mature enough that we can target it without having any of the other issues that would come from having a much, much greater number of users, concurrent users. So let's go and have a look at the enterprise mobile situations right now. So currently there are 2.7 billion workers who are without a desk. Their day-to-day job doesn't involve a desk, so they can't really get any productivity gains from classical software that's out there, or from a complex web interface that someone's trying to make them use on a mobile device. So of those, we have 427 million in manufacturing. We have a lot in all the other sectors, 226 in education, 148 million in healthcare. Healthcare and education are two areas where, I mean, it's ideal. It's an ideal ground where people don't sit at the desk all day, but they actually need access to data. Same with transportation and logistics, 189 million. And agriculture, 858 million. Now, you might think that that's out of our scope, because that might be mostly in the third world. But in Africa, people working directly with their own little farms are actually using SMS right now still to sell and buy livestock and products. And it's making a change to their lives. And in the future, they will get upgraded to the cheapest feature phones. And again, it might not be an ideal area for for Swift, because of iOS being too expensive in that case. But it's still an area that eventually might be of interest. So how do we do all of this? So we only have to build features that have proven value to the user. And yeah, it sounds a bit like snake oil salesman in the agile consulting world saying, well, only build what is proven to be useful to the user. How do we do that? How do we prove the user needs a feature? How do we prove it? Well, let's look at the usual way we do things. So usually we start with an idea, we build it, we launch it, and then we get data back from the usage. And then with the feedback, we can either get rid of that feature or just improve it or leave it as it is because it's perfect. In reality, though, this is what happens usually. So we have an idea, and that might take a while to materialize, a lot of discussions, a lot of politics. And then the build phase might be forever. You know, it might take weeks, months, sometimes years to get something to launch in many big companies, especially, you know, I don't know if you've worked in Germany and in countries where there's a lot of manufacturing old style, getting anything into production, even software, takes forever. By the time you've launched it, that data is, yeah, I mean, compared to when the idea came out, this might all be old news, and it's very hard to have this work for you. So instead, we're looking at trying to get this from an idea to data straight away, skipping build, skipping launch. So how? How do we do this? Well, I don't know if anyone here has heard about design sprints. Has anyone heard about it? Hands up. Who's actually participated in one? Good. That's good. 4 people. So I'm saying good because I was expecting even less. So I'll go through it a bit so everyone else who's here knows about it. Because was it useful for the people who did do it? Is that unanimous? Is it? Yeah. Okay, good. I just want so people know it's not a agile snake hole thing. So, design sprints. It's a structured 4-day framework for design thinking, and it lets a team scope out a business challenge, come up with a solution, prototype the solution, and then validate the solution by testing it with real users. And this is 4 days. The key thing is it's 4 days, and it's structured. And the structure means that it's not about shouting and the loudest voice prevails. So the structured nature of it makes sure, through the use of facilitators, that there are exercises that last exactly a certain amount of time. It's very time-boxed. And it's mostly about working together alone. So each person in the team, it's about 7 or 8 people working on this, with one facilitator usually. And you work on solutions and problems alone, but in a group. And then people vote on it, and there are very precise ways of dealing with it, which means that there's never a discussion. You never go through any discussion, and you are able to validate it in 4 days, which include, well, I'll go through it now so you can kind of have a better idea about it. So on the first day, you define the challenge. You have in the room, you would have someone who's the expert, or everyone usually is the expert on this. So you all sit together, and someone presents what the issue is, and then you define what the challenge is. Then everyone works to produce a mass solution. Again, they work on it alone, but together. The next day, you curate the best ones. You vote on the best solutions. You curate everything. And then you define the prototype with a storyboard. Again, all of these, it's a very regimented process, and there's no discussion at any point. And then on the third day, you design a prototype, and you build it. So the prototype can be a real prototype if you're able to do that in a day, or it might be just a paper one, or InVision, whatever the team can do. And someone in the team works on recruiting the actual users, because at that point, when on Wednesday in the morning, you already know what the product is, so you know who the audience is. So you can recruit actual people to come in, and on the Thursday, that's when you test with the prototype you've done on the Wednesday. And then you get all the feedback. And what this allows you to do is to do this. So instead of going to the build phase and spending hundreds of thousands, or actually millions usually, building something that might not give you back a good result, you get the data straight away. So you get the data, and you know it's always successful, because if it fails, you know that was a bad idea to build in the first place. So you can't lose. So if it fails, it's great, because you're not going to waste any money on that. If it succeeds, you know exactly what worked, what didn't, and then you can concentrate on building the right thing. So together alone, yeah, I just wanted to emphasize that again, because that is really important. Once you learn how to do that, there are other techniques you can do, like lightning decision jams, which are a 40-minute version of this, where you do it together alone to get through a problem. So lets you define a problem, generate and prioritize ideas, take actions and solutions, and then get a working solution that is that you arrive to without actually having to discuss anything with anyone. So you get rid of all that, the person with the loudest voice wins. And of all the politics, usually, as well. So once you have this validated idea, what do you do with it? So, well, full stack Swift development, I think for many of the cases I was talking about earlier, enterprise and a lot of other cases, is the right thing to do. Anything mobile, I think right now it's the right thing to do, because iOS is where you should start from. And you can start with a very small team. 1 to 3 pairs is the maximum. So if you're working with pairs, you don't want more than 6 people in a team. That's way too much. If you're not working with pairs and you want a small team, it could be 1 person if they can do the full stack thing. If they can't, then it should be 2 people. So you have the experience of both. So ideally, pairs consist of front end and back end, if you can do that. And then you're trying to cross-skill. So you're teaching and pairing, you're teaching the back-end developers about the front-end concerns and techniques, and the other way around. Because if you just get an inexperienced, a very experienced iOS developer, who has, as a lot of you used to be, when they first are confronted with back-end systems, they can have a lot of holes in their knowledge. And that creates a lot of issues, potentially, for the product. If they don't know how to securely save passwords, or what the best practices are generally in the back end, it can create issues. So it's good to have this cross-pollination of people from different areas working together. And then having one team deliver everything is going to cut down on all the meetings. And management that gets added to manage separate teams is never a good thing. It will always create issues, and as soon as you move developers away from each other who are supposed to be working on the same story, it's just going to be a recipe for disaster long term. And then again, user-centric, agile approach with a clear definition of done is really important. And the definition of done, to be really a good definition of done, means ship it. You can actually ship after this sprint, or even after the story is done, you can ship it. In order to do that, you have to have a team where the back end and front end are one. So one whole that's building the whole thing. And then another thing that I think we haven't heard a lot about here in these days is BFF. So it's back end for front end. And I think, well, I know actually coming from a mobile, from the client area, from the client side, you need a BFF for mobile clients. It's just consuming a general purpose API is in many cases, in most cases, not ideal. It's the reason why so many, people on the client side have started using RX Swift, and they're trying to find a way of, how do we architect it so that we can make 8 calls and then, put that information together. You shouldn't be doing that on a client. That's insane. The client should be very dumb, and the client should be making 1 call, getting 1 response back with all the data they need. Ideally, you make 1 call to change 1 parameter and you get back a whole set of other stuff instead of just getting a 200 and the object you just added or changed. I know it's a bit of a, it can be challenging for people who just work in the back end to hear this, because there are best practices, and why would you ever go away from them? But on the client side, often you want to save battery life, first of all. You don't want to appear in the when a user goes to check why their battery is dying. You don't want your app to appear there, because if it does, if it's the top, they're going to delete your app and put another one on there. So it's actually existential for many companies that their apps use the network as little as possible. So this is what a typical setup looks like with a BFF. iOS and Android are usually similar enough that they can use the same backend for front end. And what a backend for front end does is it takes away that complexity that would have been here inside the apps, and it does it behind this dotted line, which is your server, your setup. So any and all calls happen in here, and you can authenticate up here so that these are then cheaper. These calls are cheaper to make. You can also make calls to other services outside and batch all of that and give back to the client only what it needs. And potentially more information that it would have had it had to just call all of these separately all the time to sync and to get the information it needs. Important thing with BFFs is that if there's a different kind of client of different nature, it's a browser or a TV app or IoT device, you don't want to use the same one. The concerns are probably different. And how much intelligence there is in here will depend. And if you're doing it right and it's a greenfield project, you don't even potentially build these as separate services initially. They can be modules in here and you can just build this. And keeping it simple and stupid is always a good idea. So you should only be building what you need. And this has come out of a lot of companies moving from their monolithic systems into microservices and then having issues separating things out. So, but actually it can be used in greenfield projects where you just start from the BFF. You start from what that client needs. If it's the only app you have, the only client you have is that one app. And then you build more if you need them. And you only build best practice, RESTful APIs if you need them. I think some of the people talking earlier were talking about, also in the APIs, you just build the APIs you need. You don't build things because you're supposed to, because that's what it would, you'd cover everything you can cover. So, I'd stress again the definition of done and how important it is. I've worked on projects where millions were spent, huge teams working on features, where we would define it as done if the client and even our backend was satisfied that we had done all we needed to do, and there was a third-party service that we stubbed out, and that's going to come. And 6 months later, you build a product, and then it can't ship, because that never came. And it might not come for another 6 months. You might have to re-architect, because that company is out of business, or whatever happens. So the definition of done means you can actually ship it. And this is crucial. So even if within your organization, you're depending on another team building something 3 months from now, you can't do that. You just have to say, no, sorry, we can't do that. If we don't control all of it, it's not done. Personally, I've built years ago a really important feature for a product, and then it couldn't ship because another team in the same building had a different roadmap, and they couldn't build that particular thing that I needed. It was probably 1 day of work, but they couldn't do it because they had a different roadmap, different team. And that feature never got shipped, and that company later folded. It got purchased, but yeah, same thing. So, but what if you are in that situation and there's simply no way you can have the ideal situation of controlling the definition of done of everything? What do you do then? So, Swift comes to the rescue even there, because on the server side, because to stub out a third-party dependency, if you have to go down that route, which as I said before, you should never do, but if you have to, and I've done this in the past, is if your front-end developers, if your iOS developers can actually build what that API should look like, they get the advantage of being able to then use it for integration testing. So you can have a really, really good automated UI test that can, where you can inject certain headers, or there are different ways of doing it, with environmental variables and so on, where you can get that Swift server that you control to give back responses that you want to get, just to make sure that you can always test the edge cases. So that's one case where, it's not the best, but you can use it. And what if you can't do design sprints? That's only 4 or 5 people here have done them, so it's obviously not something most companies know about or want to do, because again, it's not cheap. It's 4 days of 8 people's time. I think it's cheaper than millions spent on a feature no one wants, but it's not always easy to make that case, unfortunately. So, for the enterprise world, we came up with this thing, 3.6.12, and please steal it. You're free to steal all of this. This is not a plug of any sort. I just want as many people as possible to use full stack Swift, because it is the future, and so let's share. So I've tried to do this with the customers, and it actually worked, and it's amazing. So this is for the deskless workers in enterprise. You can, if they don't want to do a design sprint, you can just send in one UX person to work with them for a couple of days, talk to the people. So we're talking about here about use cases in the enterprise where you have one specific task that someone's doing, someone who doesn't have a desk, that you could solve by giving them an app connected to their backend. And this is a very simple task usually, so it's one thing only. We created something similar, but that was a web app for shifts at the co-op in the UK, and it saved them millions, and also made sure that a lot of people stayed as one of their employees instead of leaving, and it was just around shifts, how to organize shifts. Before they were doing it with WhatsApp groups, and people would leave the company because they couldn't work out the best shifts to get, they have kids at home, they have sick parents, or whatever. You need to be very nimble and be able to organize a lot of people. So it's not, having an informal chat group is not the ideal. So we came up in 12 weeks with a solution that actually saved them millions. And you can do the same. It's much better if you did it with a native app and then with Swift on the back end. So with a limited use case of just one feature or a couple of features, you can prototype it in 3 weeks. They can try it, give you feedback. Another 3 weeks is enough to actually get something simple out there for more people to try. And then 6 more weeks, you're done. Because you don't want to add any features to it. You're doing one thing and one thing only. If they want another feature, build another app. It's cheaper. And if that certain thing doesn't work out, you don't touch the previous one because it did work. So you can get a lot of work done this way. And once a company gets one of these, they're very likely to come back for more. Because they will have, their workforce will mostly be deskless. So they will find more and more use cases where they would go, okay, if we had an app here, well, we could save millions. So this is an ideal area for Swift on the back end and front end. One thing that I didn't add here is that most companies that give phones to their users by now are giving iOS devices. When they give the choice, people usually choose iOS, so it's cheaper for them to just have iOS. So iPhones usually, or iPads in some cases. So it's ideal way to start. Yeah, and when building this, when you start with iOS, Android can always be added on top as a client, but you wouldn't be using Kotlin on the front end, back end to start a project like this because it usually makes no sense. For commercial entities, it's the fact about iOS being the platform where most money is spent. And for non-commercial ones, if it's enterprise, usually they will have iPhones over Android. So the only issue is bringing your own device situations. And in those cases, building iOS and Android natively makes sense. And starting with iOS first also makes sense because it's better to have the full stack team be iOS. And then for all the other considerations I talked about earlier. Yeah. So, keep it simple, stupid. This is just a general thing. The stupid is not the person, the stupid is the code. Whatever you do, if it's an architecture, if it's your own code, the stupider it is, the better it is. So more lines are better than less lines. I know a lot of people are very infatuated with, oh, I could do all of this in one line, but down the line, it will bite you. You need to be also inclusive. If you make stupid code and you get juniors in, they will understand the code. If you go way too clever, they will not understand it. So how are you going to bring people on board? Are you going to have them do stuff on the side for months before they can get to touch the actual code? So hexagonal architecture, it's here for the same kind of reason, as in if you architect things properly, with good separation between modules, even good separation within modules, it's easier for someone who's a junior to work on a piece of code that is simple to understand and only does one thing. They can't really screw anything else. There's no cleverness there that would mean that that one change has ramifications anywhere else. So boundaries are very important, and that's where hexagonal design comes into its own, architecture. Having really strict boundaries so that, for example, your domain code doesn't know about whether it's running in Kitura or Vapor, or whether it's running on the server or on the client is ideal. You could have a lot of intelligence. You start off with the client having intelligence because, I don't know, that's the way you started the project. If you've separated things out correctly, you can move that code to the back end later to have the same behavior apply to other clients. And it's actually important for accessibility and inclusivity as well, because you can do the same on the client side, and I've done it in apps before, for things like this, where you would have, so the core of your app, your domain, only imports Foundation. It doesn't know about database types. It has a protocol on the other side here defined that, that it uses to get any data from services or from stores. It doesn't know whether those are local or in the cloud or anything. And it doesn't import UIKit, very importantly, so that you can easily create two UIs, separate UIs, that you can then, doing something as simple as this on the client side, it's a few lines of code, but at runtime, you can load one or the other. So depending on the type of issues a user has, the type of impairment they have, they can have a different experience. And it actually doesn't cost as much as you would think. And what you get from that is that this bit here, you can move anywhere. It's just Foundation, so you can put it on Linux. And if that's your business logic all in there, testing it really easily. You can test everything really easily and have complete tests. So that was about the other considerations. And there are lessons learned. Keep it simple and stupid. Control your dependencies and their updates, as was talked about earlier. So it's very important that you, from the experience I've had so far building full stack apps, there's always the moment when you forget to lock to a specific version of one of your dependencies, and then you want to make a small change, and suddenly it just doesn't build properly, and you have to waste hours and hours fixing it. And if you make a mistake of pushing that live because it's just this one-liner, yeah, that can have really bad repercussions on your project. So always make sure to lock and test with automated tests before you push something. And then full stack Swift for mobile apps, I think, is the way to go. And concentrating on iOS initially or only is the way to go. Anyone that says otherwise, there are very few cases when you need to think otherwise. It might be government in a country where 60% of people have Android. They might have to do it in a different way. But if you can avoid that and do the full stack thing, you learn a lot. You learn a lot by working on user stories from the bottom, or the top, from the clients, from the UI the client is touching all the way to the back end, and only building what's needed for that. So yeah, thank you very much. Any questions?